Today is 14th of March 2025. NLP, very basic. First, important concept is tokenization, how to split data into primitive. There are a lot of difficulties on NLP. What is primitive data? For example, there's a lot of derivation for each of the vocabulary. We should define vocabulary in NLP. That is the first thing we should do when we also implement the model. But big vocabulary demands a lot of memory. So we sometimes choose certain vocabularies and make another words as unknown tokens. We sometimes, when we do this approach, we do characterization approach. When we do word tokenization approach, the problem is maybe there can be a lot of unknown tokens that we didn't put words in vocabulary. So another approach is characterization level tokenization. The problem then arrives is, first one is sequence of sentence gets longer. The second one is there's implication of words, but it will be gone if you split everything in alphabet level. Like cat, if you want to represent cat as pixels, then cat 3 alphabet is needed. But if you want to represent it as pixel, there are a lot of things needed, or a lot of videos are needed. So what comes out is sub-tokenization, which is split everything first, and by the frequency, we do combine each other. One of the things that usually used is byte pair encoding, which is also ChatGPT use it, which is we can represent words as x1 equals to some vector. And there's also another problem came out, which another problem is when we represent word as categorical data, then when we do weighted sum, actually categorical data to word number is just matching each other. There's no ordinary sequence that we need. But when we do weighted sum, usually high number has big weight. So there's problem when you do one-hot encoding. This is the and after that I will introduce word2vec. So I talked about one-hot encoding, and in one-hot encoding there were when you do one-hot encoding, the first problem is categorical data. If you do one-hot encoding, one-hot encoding comes out because to solve the problem of categorical data's weighted sum. But the problem is it is difficult to calculate the correlation, which is model and hotel has actually similar meaning. If you search on Google, when you search motel, you want to also search hotel, but usually in one-hot encoding, it's totally different words. And when you do one-hot encoding, the vector dimension is too large. So what we do is change one-hot encoding into denser feature vector. What we need when we do it by neural network is just a layer, just a fully connected layer, which is think of there's a sentence vector or word vector, and using fully connected layer, we will make another matrix. That's what we do. So when you also look at the code, then what we do usually is NN that layer to NN that embedding layers, which is when we do embedding, we so-called word embedding or neural word representation. So after embedding, what we do, one thing that we can do is distribution semantics, which is there is center word, and center word is defined by context word that does in other case. So this fully connected layer, what we do is one thing that we can do is like T-SNE, which is embedding maybe 3-dimensional to 2-dimensional. But when we do this, distance is preserved, which means relative distance in between word is preserved. So we can visualize in 2D how the words are similar or big. So what the word2 the word2vec model does is change it to feature vector, and after feature vector, there are a lot of classifier. First classifier, second, and third, and fourth. Maybe fourth classifier will be predict what is the next word. So important thing is we should have fully connected layer to convert the vector to another matrix. Then another question is how should we construct the loss function? In classification, we accurate. This is non-supervised non-supervised learning, so we don't have a corresponding y and y hat exactly. There's no answer, so we need to choose. The accuracy metric is important. Then we should actually choose the best prediction value first, but which is not differentiable. So the first approach is we choose surrogate loss, which is similar with the real loss. Think of label y, which is probability distribution represented as one-half vector, that there will be y and there will be y hat. Both are probability distribution, so we can minimize the loss by using KL divergence, which is KL divergence of y and y hat. Then it will be configured constitutes of constant and cross entropy. So we should minimize cross entropy. Now, how we think is there's data. There's data X, and there is model F theta. Then we should use F theta to predict Y hat. There's already things that we observed. There is data, which is Y equal to K. Then this is observed case. We should increase Y hat equals to K. Then we should minimize, which is minus log Y hat. Okay, we should minimize this one. Or another approach is perspective as likelihood. Likewise, in respect to X, we will have Y hat vector. There will be Y hat vector, Y hat vector. Then we should maximize the YK, which is YK, which is P probability of joint distribution PY1 to YK, YK, the conditional distribution of X. In this case, if we want to solve it easily, we should assume each variable's probability is independent. Then we can split it and we can make a log. And we want to minimize the log. We should minimize the log function or maximize the log. So we should just attach minus and minimize the loss. Thank you very much.